So welcome back to the next session of Green Buildings course. So let us recap whatever we did in the last video. In the last video we discussed regarding the several building materials we were discussing. So in that I have been discussed the various types of building materials that we are going to use, that is gypsum boards, concrete blocks and so on. So let me move on to the next material today, that is fiber reinforced cement components. So this is one of the predominantly used material in the case of construction practice. So first let me define, what exactly is FRC. So this is a short form is FRC, it is called fiber reinforced concrete or cement components. So this cement components is nothing but concrete. That is why it is called FRC and also fiber reinforced concrete. Okay. So let me define what exactly is. So this fiber reinforced concrete is a two-phase material. That means it is a combination of two material, which will be discretized into, one is fibers and another one is concrete. It is a two-phase material, consisting of, the fibers and a concrete. How exactly or why we need to go with fibers inside the concrete? The main thing is this concrete, which is very strong in compression, very strong in compression. That means when I am going to crush the concrete, it will take more load, or when I am going to compress the concrete specimen, it will take more load. When I am going to pull the concrete specimen, that is tension or tensile force, that means pulling it. When I am going to pull the concrete specimen, it will take very less load as compared to the compressive load. So in order to overcome this problem, what I am going to do here is, I need to reinforce this. I need to reinforce the concrete. This reinforcing will be done through the steel. Through the steel, they are going to do the reinforcement. I think in day-to-day life, you people have been observed that they are going to put the steel, or to that steel I am going to embed the concrete. That means the steel will be embedded inside the concrete to form reinforced cement concrete. So that is the as usual common day-to-day life, you people have may seen that. The next is, the advancement has happened in such a way that this RCC, that is reinforcing the steel with the concrete in order to take care of tensile force, that is tension, in this got a certain barriers, we need to overcome that. For example, this RCC will take care of very good tension. When it comes to other types of forces like toughness, like bending and so on, in that particular case, this FRC component will predominantly act as a very good material which will take care of more forces, or more parameters apart from compression and tension. For example, if you want more ductility, more toughness, more bending, if all these things is required, then this RCC is not so that much active to prevent these forces. Is it clear? Why? Because this steel will be distributed only in the particular places. But the very interesting thing about this is FRC is, these fibers will be introduced or distributed in the concrete in such a way that those fiber will be dispersed or will be scattered in such a way that, compared to the steel, these fibers will occupy all around the spaces in the concrete so that it can prevent or resist more forces. Is it clear? Okay, so hence, okay, this FRC will be the predominant material, okay, we can go ahead as compared to the concrete or reinforced cement concrete. If no reinforcement is there inside the concrete, it is just called plain cement concrete. When I am going to embed the reinforcement inside the concrete, it is called reinforced cement concrete. When I am going to embed the fibers inside the concrete, then it is called fiber reinforced cement components or composites, and or I can say FRC. Hope the definition has been clarified. Okay, so it is a two-phase material, okay, in which the concrete is reinforced with fibers, okay, in order to why? In order to enhance this mechanical properties, that is compression, tension, ductility, okay, toughness, all those things. Okay, so in order to enhance all these mechanical properties, okay, the very best suitable material is FRC. Is it clear? And I think I have not defined the ductility and toughness. The ductility is nothing but it is one of the property of the material. When I am going to stretch it, it can be drawn into thin wires or sheets. If the same specimen, if I am going to stretch, that is opposite of ductility. If I am not able to stretch, okay, immediately the failure is going to happen, okay, then that it is called brittle material. If I am going to stretch it, okay, it will elongate like a thin wires or sheets, then it is going to get breakdown. So that is called ductility. Okay, if I am not able to stretch it, immediately if there is any breakdown of the material, then it is called brittle material. The toughness is how much it will absorb the energy. That is what are the toughness. Okay, so regarding these mechanical properties, the FRC is so strong to carry these forces, hence we'll go with this advanced material. Okay, so whatever the material I am discussing today in this particular session, all these are advanced materials. Okay. Next, as I mentioned, okay, the FRC, okay, I have told that the concrete. So here, the concrete, I think I have been discussed in the last session. The concrete is made up of cement, fine aggregate, coarse aggregate, water, if necessary, admixture. So this is a combination or the constituents of concrete where we can go ahead in order to prepare the concrete. To this, I am going to add a fibers, okay, in order to prepare a FRC. Is it clear? So now, let me discuss the main thing, okay, regarding the fibers, okay, because this is a material which will play its role inside the concrete, okay, to enhance or to make the FRC. So let us go ahead to that. So hope the definition has been clarified. Okay, so now let us move on to the fibers. Okay, so fiber, okay, as I told, it is a reinforcing material. Reinforcing material. Okay, so this reinforcing material which I am going to use, okay, in order to take care of the tensile forces, okay, and these fibers, okay, I am going to add which will be short in length, okay, with and the diameter, a small diameter fiber. Okay, let us know that what are the different types of fibers I am going to use. The very first one is metallic fibers, or I can say steel fibers. Metallic fibers or steel fibers. Next, okay, it is glass fibers or mineral fibers. Next, polymeric fibers. Nowadays, this polymer is so predominant, the usage of polymer is, okay, become or created a more advancement in the engineering industries. So this polymer is also being used as one of the type of the fiber. Okay, the next is carbon fibers. So this carbon fiber is also used predominantly in the case of engineering industry in order to see the more advancement that has been happening in the engineering sector. Okay, so carbon fiber, polymeric fiber, all those things. Apart from this, these two are the commonly used fibers inside the concrete, that is steel fiber and the glass fibers. So these are the two fibers that are the commonly used inside the concrete as a reinforcing material. Apart from this, so these are all the man-made fibers. Okay, apart from this, we have a other fiber or one more type of fiber that is available naturally, which is called natural fibers. Okay, in natural fibers, we have a plenty of natural fibers. So coming to that, predominantly used in this sector is coconut fiber. So this is predominantly available. Okay, after extracting the coconut water and all those things, okay, the outer shell, that outer shell we can use it as a, okay, the coconut or coir fiber I can say. That is coir fiber. Next, okay, is sisal fiber. So this is also the availability in this particular Indian condition is more. So this is the fiber which will be extracted from the plant. Okay, so that sisal plant. So that is called sisal fiber. Okay. Likewise, we have so many other types of fiber available throughout the world, like aquara fiber and so on. Okay, and one more fiber predominantly used is jute fiber. So these three fibers are predominantly available in India, but when it comes to the all around the world, we have the M fiber, aquara fiber, so many these aquara fibers will be available in the African countries. And one more fiber, it is called elephant grass fiber. So many natural fibers are there. All these fibers are extracted from the plants or the trees, and we are going to make it as a fiber. Okay, and I can say this is the best alternative to the conventional fibers. Okay, it is the best alternative to these man-made fibers. So all these are man-made fibers, and this is a naturally available fibers. Is it clear? So with this, let me go to the properties of this fiber. So what are the properties? Okay, or I can say the different shapes. Okay, and later on we will go to the properties. The different shapes available are, it may be, okay, what I can say, usually the fibers we are going to use a different shapes. Okay, the different shapes are, it may be straight fiber. Okay, it may be crimped fiber, it will be like this, crimped fiber. Okay, next I can say something like hooked fiber. Okay, it will be having something like a hook. Okay, saddle fiber. Okay, something like a snake shape. Okay, saddle fiber. So all these are the different shapes of fiber that are available. Okay, and as I mentioned, okay, this is what the length of the fiber, and it will be having a small diameter. Okay, here the L by D ratio, that is length to diameter ratio, is very important. Okay, because this L by D ratio, or I can say the technical word is aspect ratio. Aspect ratio. So this aspect ratio plays a very important role in such a way that, okay, this aspect ratio, as the aspect ratio, L by D ratio increases, okay, there will be change in the properties of the fiber. Did you get my point? So let us discuss that, because the property is very important. So now, if we go with these properties of the fibers, okay, you can see that the steel fiber, okay, usually the properties will be classified into diameter, Okay, that is the one property. Specific gravity, that is the one more property. Okay, and the very important property is tensile strength. This is a very important thing we need to look into that fiber. Okay, tensile strength. Next, okay, elongation. Elongation. So this tensile strength will be measured in megapascal, that is Newton per millimeter square, that is strength, and elongation will be measured in percentages. So now coming to the fibers, as I discussed, that is steel fiber or the metallic fiber having a diameter varies from 5 to 500. The specific gravity of the steel fiber is 7.84. Okay, and the tensile strength will be around, I can say, okay, I think it will be expressed in gigapascal, sorry, not megapascal. Okay, that is around 0.5 to 2. Okay, so that is the gigapascal. Okay, and the elongation will be around 0.5 to 3.5%. So this is very important. 0.5 to 2 gigapascal. Giga means, okay, 1 into 10 to the power of 9. Okay, that will be 1 gigapascal. Okay, 1 into 10 to the power of 9 Newton per millimeter square. Okay, mega means 10 to the power of 6. Okay, kilo means 10 to the power of 3, like that. Okay, so giga means 10 to the power of 9. So likewise, okay, if I take a glass fiber, the glass fiber will be having a diameter 9 to 15. Okay, and the specific gravity will be lesser than steel, 2. Okay, and the tensile strength will be more than steel fiber. It is 2 to 4. The glass fiber will be having 2 to 4 GPa. Okay, and elongation will be 2 to 3.5%. That means it can elongate more. That means it can function better than steel fiber. Okay, likewise, if you take the predominant one, that is carbon fiber, then the carbon fiber will be having a 2 types, that is span based, pitch based. Pan based means polyacrylonitrile carbon fiber, and another one is pitch based. Okay, if you take that one, the specific gravity of pan based is 7 to 9, the diameter, and the specific gravity is 1.6 to 1.7, which is the advantage thing. That means I am decreasing the weight, okay, and increasing the other properties. So decreasing the specific gravity, and then the very interesting thing is carbon fiber, okay, will be having a tensile strength 2.4, maybe more than that. Okay, and the elongation is 0.5 to 1.5. Okay, likewise pitch based is same thing, about 4 MPa. Okay, and elongation will be around 0.5 to 2.4%. So like this, there will be different properties of the fibers are there. Okay, in that predominant fiber is carbon fiber. So this carbon fiber has got more tensile strength, more elongation, okay, and less specific gravity as compared to other types of fibers. Okay, and also this carbon fiber is predominantly used in the concrete, so that we can take care of this. But the steel and this are what I can say, nowadays they have been moved to the carbon fiber. Okay, usually in the repair works they are going to use more of carbon fibers. But inside the concrete, the most commonly used is steel fiber and glass fiber. But the advancement has been happened in such a way that the carbon fiber will perform better compared to other fibers. So like that, if you take the natural fibers, okay, the natural fibers, for example, coconut, okay, that is coir fiber, will be having around 4 to 6 GPa. It is very good. That means it is comparable with the man-made fibers. 4 to 6 GPa is a very good tensile strength. Okay, and likewise bamboo, you can take 11 to 7, okay, that means almost I can say bamboo is 140 to 200 GP. Okay, so likewise we'll be having a very good strength in the case of natural fiber. But the disadvantage in the natural fiber is the durability point. Okay, in the durability wise, this will not perform better as compared to the man-made fiber. That is the only barrier to use the natural fiber. That's why what they are going to do nowadays is they are going to treat that natural fibers. By treating that natural fibers, we can use it just like the man-made fibers. Okay, so this is regarding the properties of the fibers. Coming to the advantages of FRC are, it has got more tensile strength, okay, more impact resistance, that is what toughness, okay, reduce in permeability, okay, reduce in bleeding, no formation of cracks you can see in the concrete, okay, the durability will be better in the case of FRC, okay, that depends upon the types of fiber. Okay, if you use a natural fibers, the durability may be less compared to the man-made fibers, okay, FRC. Next, minimum weathering, okay, flexural rigidity is very high. So all these advantages you can obtain in the case of FRC. But the disadvantages are economy. If you use carbon fibers, these carbon fibers are very costly compared to other types. Okay, and the fibers are a little bit costly compared to the other reinforcements. And natural fibers are more preferred because it can achieve or attain economy as compared to the man-made fibers. Okay, and one more thing, mixing of fibers in the concrete is very tedious. We need to be very careful. Okay, and another thing, it requires a very skilled labor to mix it and go ahead. Because normal concrete we can handle, but to handle the FRC we require some amount of expertise. Is it clear? So this is regarding the properties and regarding the FRC. And coming to the application, wherever we want, wherever the concrete we are going to use, for example, it may be in a building, roof, okay, the runway, the roads, the bridges, flyovers, dam, in all these sectors we can use this FRC. Okay, wherever we use a normal concrete, in all those things we can go with a fiber reinforced concrete. Hope the concept has been clarified. So after discussing this, one more advanced material which I wanted to discuss is the one more material. So this is also one of the advanced material that has been happening in the engineering sector. That is same fiber which is reinforced, okay, once again, not with concrete but with polymer composites. So that is what FRP, okay, FRP composites, fiber reinforced polymer composites. So as I told, this is the latest material. A huge advancement has been happened in the construction of building also. Okay, nowadays the building advancement has been happened in such a way that the people have started to use FRP, especially in industrial buildings. Why? Because we need to create an awareness among this material. Without creating awareness among the material, we cannot go with the usage. So that's why we need to make aware of this material, okay, in the day-to-day life, so that all the, okay, those who are going with the construction, okay, they can go ahead with this type of material. Is it clear? So now, let me define this FRP. So once again, FRP is also a two-phase material in which fiber is used, which will be reinforced with a polymer matrix. In FRC, I was using cement as a matrix. Okay, now this fiber will be, okay, reinforced inside the polymer matrix to form, okay, the FRP composites. Okay, and very important thing is, which I didn't discuss in the FRC also. Okay, now I will discuss in FRP. This fiber which is going to reinforce inside the polymer matrix is very important. Not only polymer, in concrete also. How exactly these fibers will be distributed inside the concrete or polymer? Okay, that is very important. So once again, the small diameter fiber will be induced inside the polymer matrix, okay, in a continuous way or discontinuous way. Okay. Okay, the very important thing is, okay, how the fibers is going to orient inside the polymer or a concrete. That is very important. Okay, for example, if I am going to load the FRC or FRP along the direction of the fiber, that means if I am going to load like this, okay, then the FRC or FRP will take more load rather than the scattered or the discontinuous distribution. But practically speaking, we cannot orient the fibers in the unidirectional way. We cannot. It is so tough to do it. Okay, it is not possible that much. Hence, it will be distributed in the discontinuous way inside the polymer matrix or concrete matrix. So that is what regarding the definition. The reinforcing the polymer matrix, okay, with fiber is called FRP. So here also to improve the various properties, we are going with this FRP. Next, once again, okay, here as I mentioned, the main thing I want to discuss here is the matrix. That is the polymer matrix. Okay, there concrete was used as a matrix, here polymer is used as a matrix. Now, in the last FRC, okay, I have been discussed fibers. Now let us discuss more on polymer matrix. What is the advantage of using the polymer matrix? Okay, this polymer matrix will perform its function in such a way that it will glue the bundle, that means it will act like a glue or adhesive. It will glue the bundle of fibers together so that whatever the loads act on the FRP, those load will be received by all the fibers and it will be distributed. Is it clear? So that is what the interesting character of this polymer matrix. It will receive that load and it will try to distribute load, okay, all around the fibers. Okay, so that is a one advantage by, okay, gluing that fibers along with the matrix. The second advantage is it will try to protect those fiber inside the polymer so that whatever the adverse weather condition is there, so those adverse weather condition we can overcome by embedding the fibers inside the polymer matrix. That is the one more advantage. So these two functions will be performed by the polymer matrix. One is gluing with a bundle of fibers, okay, it will distribute the external load, and another function is, okay, by binding with this polymer matrix, it will protect the fibers from the external environment so that we need not to worry regarding it. So that is what I stated regarding natural fibers. Here the natural fibers we can go ahead. Why? Because those natural fibers are well protected inside the polymer matrix so that it can perform better. Is it clear? Next, coming to the polymer matrix, the polymer matrix used are polyester resin. So usually it will be called as resin or liquid, polyester resin, vinyl ester resin, and then epoxy resin. So these are the various polymer matrix that will be used, okay, as a matrix material in which the fibers can be induced or embedded inside these resins: polyester, vinyl ester, epoxy. Polyester, vinyl ester, epoxy. So these are the three types. In this, predominant one is epoxy resin. So the epoxy resin is the resin in which we are using predominantly. So coming to the what I can say, the manufacturing process. How exactly they are going to prepare these FRP composites. Okay. So coming to the manufacturing process, after knowing about the matrix, okay, the manufacturing of FRP will be done by various ways. The first one is manual method, which is called and layup technique. And layup technique. So how they are going to do? Here, first take a mold. Okay, so this will be your mold. Okay, then okay, add a epoxy or polyester resin or vinyl ester resin. Next, to this, induce the fiber. Okay, induce the fiber, and later on, through the roller, I am going to roll this FRP composite. Okay, allow it first to dry or to cure. Okay, first add a resin. Okay, then add a fiber, then impregnate it to the mold. Okay, then allow it to cure for some hours. Then roll it on the surface of the composite, so that you can prepare the FRP mat or FRP composite. So this is a manual method of preparing the FRP composite, which is called and layup technique. Next, the second one is spray up technique. Second one is spray up technique. What is this spray up technique? Okay, the spray up technique is nothing but, first, take a same mold. Okay, here we'll be having a bundle of fibers which is called rovings. Okay, just like a thread. Okay, which will be there in the sewing machine. Okay, that is what the fiber, bundle of fibers. Next, same way, okay, introduce it, the fibers, and then spray those fiber, okay, inside this, okay, the resin which already been poured, by chopping those fibers. Okay, by chopping those fiber, okay, spray that fiber inside the resin so that you can prepare a FRP mat. That is called spray up technique. Okay, likewise, one more technique is there, one more technique which is predominantly used in the manufacture of FRP, that is called pultrusion. Pultrusion technique. So this is a technique of predominantly used in manufacturing of FRP. Okay, first take a resin bath. Okay, that is called resin bath. Okay, to this resin bath, induce this fiber. Okay, induce this fiber. Okay, then this, okay, fibers which is introduced, okay, will be, okay, induced in a, okay, something like what I can say, pultrusion. Okay, that is winding machine, and later on chop it, okay, and prepare the mat. So this is another technique of preparing the, okay, that means heating it. Okay, heating is required, that is called dye. Okay, heat it, okay, impregnate it, and then prepare that FR. That is called pultrusion. One more technique is there, that is called filament winding, just like a mandrel. Okay, that is the fibers just like this, the rows of fibers will be impregnated inside the resin bath. Then those resin bath will be impregnated to the mandrel which will be revolving. Okay, to that impregnate the fibers and prepare the FRP mat. So this is what the different manufacturing process you people come across, okay, in the FRP composites. The next thing is, which is the best I can say, whether it's and layup or spray up or filament winding or pultrusion. So in this, based upon the properties, they have been classified, okay, which is best or which is okay. That is tensile strength, based upon the tensile strength, okay, and then based upon the flexural strength. So both will be expressed in MPa, tensile strength MPa, flexural strength MPa. Okay, Coming to the hand layup technique, and hand layup technique, it is 62 to 344, okay, and it is 110 to 550 is flexural strength, okay. Likewise, spray up 35 to 124, okay, and then it is 83 to 90 MPa is the flexural strength, okay. Likewise, filament winding 550 to 1380, okay, and then 690 to 1725. Likewise, pultrusion 275 to 1240, okay, and flexural strength is 517 to 1448. See, this is the tensile strength and flexural strength values. Flexure means bending. When I apply the load, how much is able to take care of that bending? How much is going to get bent without getting rupture? Okay. In this you can see, this is hand layup and spray up technique. Both these are conventional method, that is manually we are going to do. So that's why the tensile strength and flexural strength are little bit less as compared to filament winding and pultrusion technique. See, the filament winding and pultrusion technique, we can get enormous tensile and flexural strength because the manufacturing process changes over there. Okay, we are going to use a mechanized method so that we can achieve more tensile strength and more flexural strength. Is it clear? So likewise, this is what regarding the manufacturing process. So one thing I wanted to highlight here, the predominantly used polymer matrix is epoxy resin. To this epoxy resin, we can use different types of fibers. Okay, predominantly used FRP or fiber is carbon fiber. The carbon fiber is the predominantly used fiber inside the polymer matrix, that is epoxy resin, in order to manufacture these FRP composites. Is it clear? So nowadays, this FRP composite, that is carbon fiber wrapped with the epoxy resin, will be used in the repair of your building. When you want to repair your building, for example, if you want to strengthen the building, okay, then we go with this type of FRP composite. This is a very, very, very important to know. That is what the advancement. Okay, in earlier days, what we need going to do for repairing is, again we need to drill the rods inside the beam or column, okay, and again we need to do the concreting and so on. But now no need to do all those things, just it is like a sticker. Just wrap those FRP sheet to the beam or a column, that is enough. That beam and column will be enhanced with the strength. So this is the very advancement that has been happened. So I think I have been highlighted in the last video also that this FRP has been came into the existence from the aeronautical industries where it is light in weight. Why this FRP has came into the engineering sector, particularly the construction sector? Because we can make lightweight, more strong, more durable material. So this is what we require in the engineering industries, or I can say sectors. Lightweight, more strength. Strength means it may be tensile, flexure, toughness, duct, everything. Okay, and durable. That is very important. Strength, durable, and okay. But regarding economy wise, it will be little bit costly. That is the only thing we need to be overcome. Otherwise, this is the predominantly used strengthening material in the case of buildings. We can go ahead. And think nowadays the government is also coming up with this FRP technology buildings so that we can go ahead. Why this lightweight building is required? Because it can resist very good lateral loads as compared to the conventional buildings. So that's why we prefer more of FRP material rather than other material. So coming to the application wise, as I stated, this can be used in mainly bridges, because this repair work or strengthening work we come across major in the case of bridges and flyovers. So hence this FRP will be predominantly used in bridges and flyovers. Okay, likewise we can use it for other structures also, not only this thing. And whatever we use, something like the tennis bats, okay, in those threads also it is FRP. Okay, and nowadays instead of using the steel rods, regular steel rods, they are using FRP rods. Okay, the fiber reinforced polymer rods. Why? Because we can prevent more amount of corrosion. Regular steel reinforcement will be having a more corrosion. To prevent that, we can go with the FRP rods. Okay, so this FRP will be so good in such a way that it can prevent the corrosion. Is it clear? So this is what the advancement. Even in medical field also they are using this FRP material. So this is regarding the application wise. Hope the concept has been clarified. So this is regarding the advanced material which I wanted to discuss in this today's session, that is FRC and FRP, that is fiber reinforced cement concrete or cement composites, and then fiber reinforced polymer composite. That means the fibers are same, only the matrix has been changed. There in the first one, that is concrete, here it is polymer. That's it. So this is regarding FRC and FRP. Hope the concept has been clarified. With this, I am going to end the today's session. Thank you for listening.